Welcome everyone to this section on recurrent neural networks. We've already used neural networks to solve classification and regression problems in the first section of the course when we discussed artificial neural networks. But we still haven't really seen how neural networks can deal with sequence information. Just as convolutional neural networks were more effective for use with two-dimensional image data, recurrent neural networks are going to be more effective for sequence data. And sequence data can be anything like timestamped sales data, sequence of text, heartbeat data, etc. Basically, data that is expected to come in a certain order. So, a really common example of this could be a time series. Here we can see beer, wine, and alcohol sales in millions of dollars throughout time. And later on, we'll see how we can use specialized recurrent neural networks to actually forecast into the future. Sequence data also includes things like text data, where we're trying to have a sequence of words. So not only do we have sequence of continuous values, such as sales, but we also have sequences of what are essentially going to be categories, where each individual category is just a word. So then we can predict the next category or next word in this sequence. So sequences can both be continuous values, like a time series of sales data, or a sequence of actual objects or variables. So in this section, we'll begin by talking about the general theory behind what makes a recurrent neural network different. Then we'll talk about these specialized neurons that really expand on recurrent neural networks called LSTMs for long short-term memory units and GRUs for gated recurrent units. And then we'll go through a basic implementation of a recurrent neural network, talking about time series with a recurrent neural network, and then we'll show you how to deal with text data with a recurrent neural network. All right, let's get started. I'll see you at the next lecture.